Our first topic we're going to start with is your electric force from NCERT textbook, first chapter. To learn about this force, first we must learn a little bit of your gravitational force that you have covered last year. If we have a mass m1 placed in front of mass m2, there is always going to be an attractive force between these two masses, which we call as gravitational force. The force is found to be pulling one mass towards the other mass. This force was one of the most common force in those early days. The year is around 1687, and we know Newton comes up with his equation of force. The force depends on your product of the masses and inversely depends on the square of the distance between the masses. And of course, with adjustment with your gravitational constant, it takes up this form. You can see Newton is blaming mass for the gravitational force. And if you remember, mass is a property that every object has, and it tells us about the amount of matter. Now, the nature of the gravitational force is always attractive, we have seen, never repulsive. The blame goes to your mass. We have learned this gravitational force is a central force. That means one object will be pulled towards the center of the other object, and the other object will be pulled towards the center of the first object. It is also well known that gravitational force is conservative force, and it obeys inverse square law. Now, the formula given by Newton is so important for us is because with this simple formula, we have reasoned why planets go around the sun, why moon goes around the earth, and not only that, using this formula given by Newton, we can calculate how far is Mercury from sun, how far is Venus from sun, Earth is from sun, and all the other planets. Apart from this, we can even calculate the speed of these planets around the sun, the orbital speed we call it. Not only that, this formula was so good that people have used in sending rockets from Earth towards your moon, or to say to outer space. So what I want to tell you is that if we have any force in nature like your gravitational force, and if we know how the form of this force looks like, means what does the force depends upon, we can do so much more out of that. So knowing what does a force depends upon, how does a force varies, is very crucial for our understanding. Now let's go to very early days, where we have around 600 BC, person called Thales. What he used to do is that he used to take crystals like your amber, and of course he used to rub these crystals with cat fur. When he did that, he saw that this amber now had the property of attracting feathers, not repelling but attracting feathers, not only feathers but other small objects. Now clearly this attractive force cannot be gravity, because in order for gravity to work, we do not have to rub amber and cat. So obviously this was a new kind of force. One more very important reason why this cannot be gravity is that gravity is always found to be attractive, but this force that we get after rubbing amber with the cat fur is not only attractive, but it also may be repulsive, as you will see. Since it was a new force, people started calling it electric force. Now, some improvement to the theory was brought about by your Benjamin Franklin, 1706, 2300 years later after your Thales. Now according to Benjamin, he considered the reason behind this force not mass, but because of fluids which he called electric fluids. And there are two types of fluids according to him, one positive and one negative. Today if you were about to talk about this process of rubbing amber into cat fur, we would say that we have charged amber, or we would have said we have charged the cat fur. More detailed investigation on this new force was done by Charles Augustin Coulomb. And today we are still following his physical description of this force. Let's have a look at this simple phenomena or experiment where if you take a glass rod, or let's say a scale made of plastic or glass, and you have done this, you have rubbed this on your head, it is found that this glass rod has the property of attracting these bits of paper. Obviously, these bits of paper will not be attracted to the glass rod if we would have not rubbed the glass rod onto our head. And you'll see there will be no pull and no attractive force. But as we have rubbed the glass rod, we would see that there is an attractive force or pull. Today I would have said, while rubbing the glass rod onto our head, we are simply charging the glass rod. And on being charged, the glass rod has this property of attracting other objects. Let me show you that this force can also be repulsive force. I have here glass rod again. The first one rubbed with silk cloth. The second one again rubbed with your silk cloth. So I can say that I have charged the glass rod number 1, I have charged the glass rod number 2. By symmetry I can say whatever has happened to the first glass rod has also happened to the second glass rod. So if I have made the first glass rod positively charged, I must have also made the second glass rod positively charged. Now if I bring the glass rod closer to each other, we notice that these two glass rods are going to have some degree of repulsion against each other. Hence we also have this repulsive force. You can make out where are we heading to. We are trying to write the form of this force such that we have properties on which we can blame this force upon. And clearly the experiments have shown that the objects has to be charged so that we can talk about this force. Now moving on, before we proceed to the actual form of this force, we need to have a better understanding of what is known as charge. It is an intrinsic property of elementary particles of matter which give rise to electric force between the various objects. So in order to understand this new force, today we have this model of an atom where we have tiny particles like your electrons and protons. So basically we are going to bring the electrons and protons, blame that they have a property called charge, and then reason out the existence of electric force. In simple words, I'm trying to say is that when we are rubbing the glass rod with your silk cloth, these electrons and protons inside the glass rod and in the silk cloth are the reasons why they develop a property of attracting or repelling other objects. So what is electric charge? Electric charge is an intrinsic property of elementary particles which gives rise to electric force. The elementary particles are your electrons, protons and neutrons. Electrons are found to have a mass of 9.1, 10 to the power minus 33 kgs. Protons are found to have a very big mass compared to electrons, 1.6726, 10 to the power minus 27 kgs. And finally your neutrons are found to have a mass of 1.6749, 10 to the power minus 27 kgs. They are a bit heavier compared to your protons. Now on the other hand, we are saying that the electrons are also going to have property called charge. It was assigned that the electrons will have negative charge. The amount of negative charge that electron has is 1.6 into 10 to the power minus 19 coulombs. The C here stands for coulombs, and that's the SI unit of your charge. Then we have protons, or protons have been found to have a charge of 1.6 into 10 to the power minus 19 coulombs of charge, and the property or the nature of this charge on the proton is opposite to that of your electrons. That's why we have assigned it a positive sign. And finally, it is found that neutrons have no charge, or in other words we can say they are neutral. So you can see here we have this new property called charge on the electron, charge on the proton, or let's say charge on the neutrons, just to explain this new force which we call as electrostatic force or electric force. If we do not talk about this new property given to this elementary charged particles, we will never be able to explain the reason behind your electrostatic force. So clearly I can say electrons are your negatively charged particles, protons are positively charged particles, neutrons are. We are going to use our small letter E in our formula and expressions to denote elementary charge. And the value of this elementary charge is 1.6 into 10 to the power minus 19 coulombs. Hence, instead of writing minus 1.6, we have written just minus E, which represents again minus 1.6. and here we have taken it to be plus E, which means plus 1.6 into 10 to the power minus 19 coulombs. Let's look at some examples where we will have some better understanding of your charge on an object or an atom. We start with the simplest atom here first, which is your hydrogen atom. You know it has one proton, it has one electron. So to calculate the net charge on hydrogen atom, we can calculate the net mass. As you can see, I'll just simply add the mass on electron, add with the mass of proton, and I must get the total mass of your hydrogen atom. Similarly, to calculate the net charge or the total charge on hydrogen, we're going to take the amount of charge with the proton, add with the charge on that electron that we have. When we do that, I must write plus E plus 1.6, add with the negative 1.6 of your electron. So when we do that, we get 0 coulombs of charge. And I have to say that this hydrogen atom right now is neutral. What it means right now is that I can say this hydrogen atom as a whole is uncharged. And I can also say the reason is that they have equal number of electrons and protons. The positively charged protons cancel out all the charge in the negatively charged electrons. Again, if I go to helium atom, we know there are 2 electrons in a helium atom and we have 2 protons. So again, if you calculate the net charge on helium atom, I must add charge of proton multiplied by 2, charge on electron multiplied by 2. When we do that, we get twice of plus E and then plus twice of minus E. And again, you can see we are going to get 0 or no charge. Hence again, we are going to say that helium atom is neutral. Again, I can comment that helium atom had equal number of electrons and equal number of protons, because of which whole helium atom is neutral. Moving on to carbon atom, also you can see the configuration is 2, 4. That means we have 2 electrons in the first shell, 4 electrons in the second shell, and of course we have 6 protons in the nucleus. So again, you can see we have taken 6 times the charge on each proton, 6 times the charge on each electron, and when I solve this again, we are going to get 0 or neutral. So I can easily say the atoms with equal number of electrons and protons are going to be neutral. Now this is not only true for atoms, but this is also true for any other object that you see around. If you have equal number of electrons and protons, that object is going to be neutral. That's why if I take a glass rod and tell you that glass rod has atoms of glass, or let's say molecules of glass, at first these molecules, or let's say glass rod, will not be able to attract bits of paper, and I can simply reason out that glass rod has equal number of protons and electrons, because of which glass rod is neutral. Hence we cannot talk about your electric force, and that's why the bits of paper were not attracted by your glass rod. But you see, on rubbing, we are going to remove some of the electrons from this glass rod, and when we do that, this glass rod no longer has equal number of protons and electrons. Now why we can remove electrons, you can think it like this. Electrons are very light compared to your protons, and protons, they are very much fixed. So electrons being present on the outer surface can be knocked out by friction, that is by rubbing, and hence this glass rod will no longer be neutral because it has lost some electrons and they do not have equal number of protons and electrons. Hence I have to say that we have charged the glass rod, and that's why it starts attracting the bits of paper. I think you already got an idea where we are heading to, so let's proceed. Now how to make an atom charged? Let's look at hydrogen atom. So you see, we have an hydrogen atom here, and I've taken the electron from this hydrogen atom and we have ionized it. That means we have removed. So if we do not have this electron here, the atom is simply going to have just a proton. Now if you calculate the charge on this H plus ion, we must write charge on proton plus, of course, nothing, 0, and I must get plus 1.6 10 to the power minus 19 coulombs. Clearly I can say your hydrogen atom was uncharged or neutral, but when the hydrogen atom loses one electron, you can see that it becomes H plus ion, and it is found to have a positive charge. Here I can comment that if an atom is losing electrons, that atom must become positively charged atom. One more thing, notice this is the charge on the hydrogen atom after it has lost one electron. In the next example again, we have here sodium, where we have electrons, 11 electrons arranged in the shells with the 11th electron on the last shell. Again, if we somehow remove this electron, you will notice we will still have 11 protons in the nucleus, but we will be left out with only 10 electrons. So if you calculate the net charge on sodium ion now, you will see I must take the charge on 11 protons, which is 11 times of 1.6 into 10 to the power minus 19 coulombs with a plus sign. I must add it with charge on 10 electrons, which is minus 10 times of 1.6 into 10 to the power minus 19 coulombs. You will see we will be left out with only plus E. This plus E again means plus 1.6 into 10 to the power minus 19 coulombs. The thing here to note is that hydrogen lost is 1 electron, became positively charged, equal to a value of 1.6 10 to the power minus 19 coulombs, and even your sodium, after losing 1 electrons, has gained a charge of 1.6 into 10 to the power minus 19 coulombs. So what I can say now is that whenever there is a body or an object or an atom, if it loses its 1 electron, then the object should become positively charged. And how much positively charged? It should become, or it should have a positive charge of 1.6 into 10 to the power minus 19 coulombs. Let's look at this case where if an atom is not losing electrons but actually gaining electrons. To tell you, chlorine already has 17 protons in its nucleus and 17 electrons in its shells. Now this electron, the extra electron, when added, the equation will look like this. 17 positive charges because of the protons and 18 negative charges because of the electrons. When we solve this, we are going to left out with minus E, which is nothing but minus 1.6 into 10 to the power minus 19 coulombs. So you can see here, it's very simple. If an atom is gaining electrons, or let's say is getting some extra electrons, then that atom should have some charge, negative in nature, and if it is gaining one extra electron, it should have a charge of minus 1.6 into 10 to the power minus 19 coulombs. So the note here you all should take is that when a neutral body gains electrons, it must become negatively charged. When a neutral body loses electrons, it becomes positively charged. So suppose if I just draw a box, call it a body or an object, and I tell you that charge on this body is equal to plus 1.6 into 10 to the power minus 19 coulombs. You can easily say that this body does not have equal number of electrons and protons. What else you can say is that the number of protons in this body must be equal to 1 more than the number of electrons in this body. Or in other words, I can say this body has 1 less number of electrons compared to the number of protons. If they were have to have same number of electrons and protons, you know their charge in this body would have been 0. So to wrap up, we need a property called electric charge, without which we cannot explain a force called electric force. This charge is measurable in the units we use as coulombs. This charge has nature, it has two natures, it has positive nature and negative nature, which are opposite to each other. And hence we have to say that it is a scalar quantity. Charge do not have direction. Then there are smaller units of this electric charge. In CGS system we call it stat coulombs, ST capital C. This stat coulombs is related to your coulombs with this formula where we can write 3 into 10 to the power 9 stat coulombs is equal to your 1 coulombs. You can see 1 coulomb is very big unit and stat coulombs is a smaller unit. Other name for your stat coulombs or CGS system is your Franklin FR we can use. We can also use electrostatic unit of charge. And finally, we have used the symbol E to represent something called electronic charge with the value of 1.6 in 10 to the power minus 19 coulombs. We do not have a plus or a minus here. We simply have that number. You have seen we have property called mass, and now we also do have another property called charge. In chemistry you must have learned something called conservation of mass. In physics we do not talk about conservation of mass. There's a reason which we can discuss later. Now, but charge in physics is always conserved. The idea is very simple. It means the total charge of an isolated system must be constant. In other words, we can also write electric charge can neither be created nor it can be destroyed, but it can only be transferred from one body to another. To explain you this, let's take up this example. If you remember, we have this silk cloth and we have our glass rod. Let's say glass rod is neutral even your silk cloth is neutral. And you understand that it means they have equal number of electrons and protons. Now, the atoms in glass rod are very rigid. It's very difficult to displace them. When we rub this glass rod with the silk cloth, the atoms cannot go from glass rod to silk cloth. But you will notice that the electrons, they can be transferred from glass rod to your silk cloth. So clearly I can say glass rod is losing electrons and I can say silk cloth is gaining electrons. And then I can even say your glass rod becomes positively charged and your silk cloth becomes negatively charged. So before rubbing you can see charge on the glass rod plus charge on the silk cloth must be equal to 0 plus 0 because they were neutral. But after rubbing, your glass rod becomes positively charged, let's say Q, and your silk cloth becomes negatively charged. Now why I have written Q and Q is because if the glass rod loses one electron, it starts having a charge of 1.6 10 to the power minus 19 coulombs. And if the glass rod is losing that electron, it will be gained by your silk cloth, because of which the charge in your silk cloth will become minus 1.6 into 10 to the power minus 19 coulombs. And if you calculate the total again, you will see it has become 0. So you can say before rubbing the total charge is 0 and even after rubbing the total charge is 0. So what we can say here is that the total charge is 0 even if there is a transfer of charge or the appearance of charge on both the bodies, the total charge is always going to remain constant. So what I have written here is that when the glass rod is rubbed with silk cloth, glass rod develops a positive charge, but at the same time silk cloth also develops equally negative charge. Hence before rubbing you can say net charge on the glass rod and the silk cloth is 0, and even after rubbing the net charge on glass rod and the silk cloth should be equal to 0. Now what we can do next is that we can compare the differences between your charge and mass. Both are properties we know. First of all, mass of a body will always be positive. We cannot have a negative mass. We do not need it because we don't have a repulsive gravitational force. But whereas charge has to be either positive, negative, or it has to be 0. Because you have seen we have attractive electrostatic force, repulsive electrostatic force, and sometimes there may be no electric force. So electric charge can be 0 as well. Next thing, charge is conserved. We have seen already. But to tell you, some of you may have doubts, mass is never conserved in physics. We do not talk like that. We never talk about conservation of mass in physics. You will see later, Einstein comes with his equation and writes mc square. Instead of talking about mass, we can talk about energy. It's like your mass can be converted into your energy. That's why if you calculate the total mass on the left hand side and right hand side, you may not get equal amount of mass. It's because some mass may have been converted into energy. Hence we cannot say that mass on both sides are equal. Next thing is that a charged body always possesses some mass. Now it is simple to understand. If we have an object and let's say it is charged, positive charge or negative charge. If it is positive charged, I have to say that the number of protons is greater than number of electrons. And if it is negative charge, I have to say the number of electrons is greater than number of protons. In any of the case, since the protons or the electrons, they have mass, that's why a charged body should always have some mass. Whereas a body may possess mass, but it may have no net charge. That means the net charge may be equal to 0. And this is also possible because if you have two protons, like your helium, and you have 2 electrons, notice you will have mass because you have protons and electrons, but the net charge will be equal to 0. That means it is not necessary for a body which has mass to also have net charge. Another thing which you can say is that charge on a body is independent of the motion. That means if we have a body or an object and it's moving or not moving, it will have a charge called Q, which does not change or does not depend upon its velocity or motion. Whereas mass, according to Einstein, is found to change if the velocity of the body is increasing or changing, or let's say decreasing. That means mass is not a constant. Another thing which you can note here is that electric force between two charges may be attractive or repulsive, whereas gravitational force between two masses is always attractive. Next, we have a very important topic called quantization of electric charge. To understand this property, let's have a look at this example. Here, suppose first we have a body or an object that is neutral, equal number of protons and electrons. Let's say they have 1000 and 1000 of them. So we have 1000 protons and 1000 electrons. Now the simplest thing that can happen with this box is that it can lose one electron or it can gain one electron. If it loses one electron, the number of protons will be 1000 or still 1000, but the number of electrons will become one less, or I can say number of proton is one greater than the number of electrons. If you calculate now the total charge on the body, earlier the total charge was 0 because you see they had equal numbers, but now if you calculate the total charge on this body after losing one electron, we will get 1000 minus 999, we will get 1, or let's say 1e plus 1e. That is your plus 1.6 into 10 to the power minus 19 coulombs. So the body is charged and charged to this value. If instead of losing one electron, the same body or the object gains one electron, then the number of electrons will be equal to number of protons, which is 1000, plus number of electrons gained. Now if you look at the number of electrons, it must be one more than the number of your protons. So we have the same number of protons as 1000, but we have now 1001 number of electrons in the box. Clearly 1000 minus 1001 will give you minus 1 or minus 1e, because of which I'm going to write minus 1.6 into 10 to the power minus 19 coulombs. That means this box can have a charge of 0 if it is not losing or gaining any electrons, but the same box after gaining or losing electrons will have a charge of plus 1.6 or minus 1.6. So we have written it, charge on the body in the most simplest case after losing or gaining one electron will be 1.6, or we can write equal to plus minus e. Here you can say we have 1 in front of it, and depending on whether you are losing or gaining, you are going to use plus or minus. Now the next simplest case that can occur here is that the body may lose 2 electrons or the body may gain 2 electrons, because of which the number of protons here in this case will be 2 more than the number of your electrons. That is, since it has lost 2 electrons, the number of electrons is 998, and it had 1000 protons, so it has 1000 protons. When I calculate the total charge now in the body, we are going to get plus twice e, or we can simply write plus twice plus 2 into 1.6 10 to the power minus 19 coulombs, which is equal to your 3.2 10 to the power minus 19 coulombs. Similarly, if the body was to gain 2 electrons compared to its neutral state, is going to have 1000 protons, but is going to have this time 1002 electrons, because of which when you solve this equation to find the total charge on the body, writing total charge on the proton and total charge on the electrons, we are going to get minus twice e. You can see the body has excess of electrons. So we are going to get minus twice e, which is equal to a minus 3.2 into 10 to the power minus 19 coulombs. So we can say the body can have a charge of 3.2 into 10 to the power minus 19 coulombs if it is losing or gaining 2 electrons. So on, if I simply write plus 5e or minus 5e, it means the body must have lost 5 electrons, and this means the body must have gained 5 extra electrons, because of which the total charge becomes 8 into 10 to the power minus 19 coulombs, plus or minus. So I can say the body can have a charge of plus e or minus e. The next it can have is that plus or minus twice e. The next after that it can have plus or minus thrice e, 4 times e, 5 times e, and so on. If we write plus minus ne, you can make out that this n represents the number of electrons lost or gained by the body. But notice, we are not allowed to write plus or minus half of e, plus minus 3.2 of e, plus minus 3.5 of e. These values are not allowed because writing plus minus half of e simply means that we have lost or gained half of the electron. Now obviously you cannot take an electron, divide into half and expect half of it to be lost, half of it to remain in the atom. Since this possibility is not there, we cannot have a fraction in front of your e. We can only have these whole numbers like 1, 2, 3 and 4. So here you can see we have written charge on a body should always be equal to plus or minus, depending on losing or gaining electron, n times, which is number of electrons, times E, which is the charge on each electron or proton. So here we have the possibility of the value of charge is 1.6 after losing or gaining 1 electron. The next possibility of the value of charge is plus 3.2 10 to the power minus 19 after losing or gaining 2 electrons. And finally we have a value of charge on the body to be equal to 4.8 after losing or gaining 3 electrons, and so on. What we cannot expect here is that to have a charge of 1.7 into 10 to the power minus 19 coulombs, we cannot have a charge of 3.3 into 10 to the power minus 19 coulombs. We cannot have a charge of 4.5 into 10 to the power minus 19 coulombs. So a body is very much restricted to have values of charge, and they can only be this, or multiples of your E, 1.6. An analogy to this is that if you have 10 rupees notes with you, the total may be 40 possible, the total may be 50, which is also possible, the total may be 60, 70 and so on. But we can never expect you to have total of 55. You can simply consider these as packets, and this is the total number of packets you may have. And this possibility clearly does not arise. The same thing happens with your charges also. You may have a charge of E, which is 1.6. You may have a charge of 2.E, where E represents your individual packets. You can have 3E, 4E, but no chance of having 1.1E, 2.2E, 3.3E. This property that I have discussed just now is what we call as quantization of charge. It simply means that any observable charges that we see around us will always be equal to a multiple of your elementary charge, that is Ne. And since we have written its integral multiple, this n must be a whole number. It cannot be a fraction. In other words, we can also say quantization refers to discrete nature of charge, which means non-continuous values of charge. Quantization comes from another word you can say, which is quantum, which refers to packets. So here you have seen the values of charge cannot be continuous. It cannot be 1.6 into 10 to the power minus 19. It can be 1.6 10 to the power minus 19, but it cannot be 1.7 into 10 to the power minus 19 coulombs. The next possible values of charges allowed is 3.2 10 to the power minus 19 coulombs, which is simply a multiple of your 1.6. And hence we have this very nice formula that we have. We write Q equals to plus minus Ne. Now the reason behind this quantization is very simple. Is because of the fact that we can only transfer integral number of electrons, not fractions, but only integral numbers. Hence the charge transfer also will be multiples of E, but not in fractions of E. So here we have, so you can say we have got the first formula in our electrostatics, that is your Q equals to N plus E. Let me tell you again how to use this formula. Q represents charge on a given body. Plus has to be used if the body is losing electrons. Minus has to be used if the body is gaining electrons. N has to be the number of electrons lost or gained by the body. And E is simply our electronic charge or elementary charge. Let's quickly look at this next question, which is often asked in your board. Conceptual question. Question says, is the charge of 5.8 10 to the power minus 18 possible or not possible on a given body? In order to do this, we are going to use this rule where Q will be this value of charge. We are going to calculate N over here to find out the number of electrons lost or gained by writing N equals to Q divided by E. Put the value of Q, put the value of E that we have, and we got clearly here 36.25. You can say N is equal to 36.25. Clearly the rule, the quantization rule that we have, doesn't allow N to be a fraction, that is a 36.25%. And we have seen that N only has to be a whole number. That means either it has to be 36, which represents 36 electrons transferred, gain or lost, or it can be 37, but the number of electrons cannot be 36.25. Since the number of electrons lost or gained cannot be 36.25, even the charge of 5.8 10 to the power minus 18 is not possible. Hence we have written this number is not an integer, hence the charge is also not possible. In the next question, they are asking how many protons or electrons do we need in order to have a total charge of 1 coulombs. Now 1 coulomb is a very big charge, so it must have lots and lots of electrons or protons so that we get total of 1 coulomb of charge. So clearly given Q is 1 coulomb of charge, how many number of electrons or protons are going to give us so much amount of charge is unknown to us. We are using the formula that we have learned. From here we are going to write N equals to Q by E. Q is 1 coulomb of charge we are talking about. E is 1.6, and on simplification we are going to get 0.625 10 to the power 19, not minus 19 but 19, or we can write 6.25 10 to the power 19. This number is 625 followed by 17 zeros, 1 2 3 4 5 6 7 8 9 10 17 zeros. So clearly you can see it is not a fraction, but it is an integer or a whole number. So of course this value of N is allowed. Or I can say if we have so many electrons or if we have so many protons, then the body can have a charge of 1 coulombs, either plus or minus. Next question we can discuss here is that we have been given here a metallic sphere with a charge of minus 6.5 microcoulombs. This symbol is for micro, 10 to the power minus 6. 15 into 10 to the power 13 electrons are removed from the sphere. What would be the net charge on it? So clearly our body, the sphere, already has a charge, let's call it Q1, which is 6.5 minus 6.5 microcoulombs. And from this body you can see we are removing electrons. Now we have written the charge already present in the body. Now we are writing the number of electrons removed from the charged body. Since these many electrons are going to be removed, there will be charge gained by our body. It is not going to be negative, but it will be positive charge gained by the body after removal of the electrons. So we are writing Q2, which is the amount of charge gained by the body after losing n number of electrons, which is this, and that is 5 into 10 to the power 13 into 1.6 into 10 to the power minus 19 coulombs. This number comes out to be 8 into 10 to the power minus 6 coulombs. Now if you recall, the body already has a charge of minus 6.5 microcoulombs. Now after removal of electrons, it gains a positive charge of 8.0. So simply we are going to add both the charges Q1 and Q2. The first one is negative and the second one is positive. And if I do that, I'm going to get the net charge, which is going to be 1.5 into 10 power minus 6 coulombs, which we can write minus 1.5 microcoulombs. So in this problem you saw that the body may not be in the neutral state and can still lose or gain electrons. And net charge always has a formula of Q1 plus Q2, where you must take care of their signs properly.